of in thermal expansion, the basic thing we always try to remember is distance between any 2 points increases due to rise in temperature. Any metallic plate, if there may be the shape of the body, if you are increasing, there will be increase in all the dimensions part of relation. Is that point clear? In this one, we are having three types of your expansions better. The first one is known as of your linear expansion. First one is known as what for your linear expansion, represented by your alpha. Coefficient of linear expansion is represented by your alpha. Formula gurtunda, change in length will always be directly proportional to your original length and also your temperature difference. Removing that, we are getting some constant known as of your alpha. Alpha is known as what beta? Coefficient of linear expansion. Okay, what is the value of your alpha? Alpha is known as of your coefficient of your linear expansion.
Yes, sir.
That means alpha is equals to your change in length divided by original length into your change in temperature. That means I can write this one as of your L2 minus of L1 divided by your L1 into your temperature difference at T2 minus of your T1. That will be your alpha. And unit will be equal for this one, but this length will get cancelled. The unit will be equal to your how much for me? Either it is in the kelvins or it may be in the degree centigrade. And then 1 by temperature, that means 1 by K. Or maybe 1 by degree centigrade. That means C inverse and raskochu. Lekapote Kelvin inverse and right. And then
Yes, sir.
okay. So what do you mean by alpha beta? Alpha is known as of your coefficient of linear expansion. Coefficient of your linear expansion. And one more term in this one is right now for me, superficial expansion. Superficial, or we also call it as of your aerial expansion. We also call it as of your what? Aerial expansion. Okay, that means expansion in what beta? Two-dimension bodies.
Yes, sir.
Linear expansion means expansion in your one-dimension bodies. So when I'm talking about the linear expansions in in area, so change in area will be equal to your some initial value, that is nothing but of your A naught into your some constant beta into temperature difference, same like of this one above. In the place of length, we are writing right now for your area, and in terms of alpha, we are writing the value of your beta per deflation. That means beta value will be equal to how much beta? Beta is equals to your change in area divided by original area into your temperature difference. That means I can write this one as of your A2 minus of A1 divided by A1 into temperature difference. That is T1 minus T2. Sorry, T2 minus T1. Higher temperature minus lower temperature.
Yes, sir.
This will be your T2 minus of your T1. Again, units are same for this one also. Beta is known as what beta? Coefficient of your aerial expansion. Coefficient of your coefficient of aerial expansion.
Yes, sir.
Then beta. The next one is very important formula, that is about your volume expansion. Volume expansion. Okay. Volume expansion. Volume expansion, how do you represent it, beta? Represented by your same this relation, delta V will be equal to your original volume into some constant gamma into your temperature difference delta T. That means gamma will be equal to your change in volume divided by original volume into change in temperature. Or else I can write here gamma is equals to your V2 minus V1 divided by your V1 into temperature difference T2 minus of your T1. So this will be the value of your gamma. Clear, beta?
Yes, sir.
Unit will be same again. The gamma is known as what beta? Coefficient of your volume
Expansion, volume expansion.
So this one is known as of your coefficient of your volume expansion. Coefficient of your volume expansion. And relation between them is very famous beta. We are having relations between them. So one is beta is equals to 2 times of your alpha and your gamma is equals to your 3 times of your alpha. So if I'm writing the relation between alpha is to beta is to gamma, this one is alpha is to beta is 2 times of alpha is to this one is 3 times of alpha. So ratio will be equal to how much beta? 1 is to 2 is to 3.
Yes, sir.
Sure. Next one is effect of temperature on your density. Effect of temperature on density. Very important point. What happens when you increase the temperature to the mass, volume, pressure, densities? These are very, very important for solving the numerical particulation. Density formula gurtunda. Initial density will be equal to your mass by your initial volume. Final density is equals to mass divided by your V final. Mass will be remaining same, but densities will be changing. V final means what beta? Change in volume only na. So I can write this one as of your M divided by, this is nothing but V2. V2 will be equal to how much for me? V initial into 1 plus gamma into delta T. Can I write like this?
Yes, sir.
From here I can write this one. V2 minus V1 is equals to gamma into V1 into T2 minus T1, right? Isn't it? That means
Yes,
V final minus V initial is equals to your. So this one will be equal to how much better right now? This one is nothing but of your V initial into your, this one is gamma into your T2 minus of your T1. So if I'm taking V initial on this side, so this will become how much for me? V final is equals to Vi common. It is 1 plus gamma into your delta T, right?
Yes, sir.
So so V final is equals to V initial into 1 plus gamma into delta T. And final density will be equal to your mass by initial volume can be written as beta. Mass by initial volume can be written as of your initial density. So that can be written as of your rho I divided by 1 plus gamma into delta T. Okay, now?
Yes, sir.
So final density will be equal to your initial density into 1 plus gamma into delta T. If gamma into delta T is much lesser than 1, then in that case, final density will be equal to your initial density into 1 minus gamma into delta T. You can use this formula. Final density is equals to your initial density into 1 minus gamma into delta T.
Yes, sir.
Clear, beta?
Yes, sir. సార్ దీంట్లో నుంచి 1 క్వశ్చన్ వస్తుంది కదా?
ఈ ఏరియా నుంచి 1 క్వశ్చన్ వస్తుంది. థర్మల్ ప్రాపర్టీస్ ఆఫ్ మ్యాటర్స్ నుంచి 2 క్వశ్చన్స్ కూడా రావచ్చు. థర్మల్ ప్రాపర్టీస్ ఆఫ్ మ్యాటర్ లో థర్మల్ కండక్టివిటీ అండ్ క్యాలరీమీటర్ అండ్ యాజ్ వెల్ as థర్మల్ ప్రాపర్టీ మొత్తం 2 to 3 క్వశ్చన్స్ రావచ్చు దీంట్లో నుంచి.
Yes, sir.
Next one is effect of temperature. This is a very important formula on pendulum clocks. On your pendulum clocks. Pendulum clocks చూసావు కదా నువ్వు? Isn't it?
Yes,
During
sir.
summer and winter, what happens? The length of the pendulum will be either increasing or decreasing.
Yes,
Like,
sir.
for example, this is your pendulum right now here, and this is your bob. The length is your L, and this is oscillating here to and fro like this. Isn't it? Seconds pendulum means what beta? The pendulum, it is been oscillation of your one pendulum is how much for me? 1 second. That means it will make one oscillation close to almost all of how much in 1 second. Seconds pendulum.
Sorry, sir.
What do you mean by seconds pendulum beta?
The time period second untadi.
The time period of the pendulum, whose time period is equals to 2 seconds. That
Yes,
means I can say that for one oscillation of the pendulum clock shows how much time? 2 seconds and another. One
Yes,
oscillation అంటే మీన్ నుంచి ఎక్స్ట్రీమ్ వెళ్ళి ఎక్స్ట్రీమ్ నుంచి మీన్ కి వచ్చి మళ్ళీ మీన్ నుంచి ఎక్స్ట్రీమ్ కి వెళ్ళి ఎక్స్ట్రీమ్ నుంచి మీన్. ఈ ఒక్క
Yes, sir.
ఆసిలేషన్ కి టైం ఎంత పడుతుంది మనకు 2
2
సెకండ్స్.
seconds.
దాన్ని మనం ఏమంటున్నాము సెకండ్స్ పెండులం. సో టైం పీరియడ్ విల్ బి ఈక్వల్ టు హౌ మచ్ ఫర్ మీ సింపుల్ పెండులం t is equals to 2 pi under root of your L divided by G. గుర్తుందా?
Yes, sir. 2 pi root L by G.
Now when the temperature is increasing better, when temperature is been increasing, length of the pendulum will be increasing. Okay, if length is been increasing, so what is happening to the time? Here t is nothing but what better time period. T is nothing but what here right now for me time period. So time period is increasing. Temperature I am representing it here by your theta beta, not with your t. Okay now?
Yes, sir.
In the same way, when temperature decreases, that is delta theta. So what is happening to the length? The length also decreases. When length decreases, the time period also decreases. When time period is decreasing, it will go either fast or gain. It will gain the timeline, isn't it? And when the time period is been increasing, the clock will become slow or loses your time, I can say. Okay now?
Yes, sir.
So in this one, clock becomes slow, or I can say it loses time. So I hope you got an idea when it will lose the time. It's very important. When it will gain the time.
సార్ ఒక క్వశ్చన్ వచ్చింది సార్ పెండ్యులం నుంచి. ఒక పెండ్యులం ని హైట్ నుంచి రిలీజ్ చేసినారు, అంటే త్రో చేసినారు. అట్ రెస్ట్, ఇనిషియల్లీ రెస్ట్ లో ఉంది, ఏదో హైట్ హెచ్ ఉంది. సో వాట్ ఇస్ టైం పీరియడ్ అని అడిగిండు.
When it is been free fall, huh?
Yes, sir. Free fall.
One oscillation, beta. If it is been free fall, the time period will be equal to how much? That depends upon the length. Length data name ఇవ్వలేదా?
లేదు, ఏమి ఇవ్వలేదు. జస్ట్ ఫ్రీ ఫాల్ లో అంతా ఇచ్చిండు.
ఫ్రీ ఫాల్ ఉన్నప్పుడు టైం పీరియడ్ ఏంటి? T is equals to 2 pi under root of your L by G plus or minus small a.
Yes, sir.
So in free fall, acceleration will be equal to how much for me?
G.
So when it is your G right now for me, when it is in a free fall, A value will become for me G. So time period will become how much? 2 pi under root of your L by your 2G.
Yes, sir.
Isn't it? So what is happening to time period? Increases or decreases? Length is decreasing. When length is decreasing, then time period will also be decreases.
Yes, sir.
Okay. Options same ichadu.
1, 2, 0 and 4.
Obviously, what is the time period I can write? Time period is been decreasing. One oscillation ki time period enta right now for me? T
2
is
seconds.
equals to your 2 seconds. Right now in the length enta unte L. Now length is becoming how much for me? L by 2 kada.
లేదు లేదు సార్, ఆయన సెకండ్స్ పెండ్యులం అని చెప్పాలి, సింపుల్ పెండ్యులం అన్నాడు.
అవునా? టైం పీరియడ్ ఈజ్ ఈక్వల్స్ టు జనరల్లీ ఒక పెండులం కి ఎంత అవుతుంది? 2 సెకండ్స్. అంటే లైక్ సే ఫర్ ఎగ్జాంపుల్ టైం పీరియడ్ T is equals to one simple pendulum T is equals to 2 pi under root of your L by G అనుకుందాం.
Yes, sir.
When it is free fall, T dash will become how much for me? 2 pi under root of your L by this one. How much I'm getting? 2G kada.
Yes, sir.
That means this will become how much for me? Your 2 pi under root of your L by G into your 1 by root 2. That means it is L by your root 2 time period T dash.
Yes, sir.
Isn't it? So that means this will become for me how much? L by root 2 value is 1.414. What are the options he has given?
1, 2, 0 and 4.
1, 2,
0, 4. ఆన్సర్ 0 అని ఇచ్చిండు.
time period will be equal to your 0. When it is into your question ఏమన్నా ఇచ్చా డేటా ఇంకా?
సార్ నేను నీకు క్వశ్చన్ పంపిస్తా. ఏం డేటా అయ్యలేదు సార్, జస్ట్ అన్నాడు హైట్ హెచ్ నుంచి ఫ్రీ ఫాల్ అవుతుంది.
క్వశ్చన్ పంపించు సార్.
అవును సార్. సార్ ఈరోజు 9:30 అది ఉందా పేపర్ డిస్కషన్?
ఉంది నాన్న.
ఓకే సార్.
Sure. So I hope you got an idea how to calculate the time period loss or gain.
Yes, sir.
Isn't it? So when it will become slower, when it is losing the time means when the time period is increasing. When it is gaining the time means when time period is been losing participation. Okay.
Yes,
And
sir.
one more important area on this one is your thermal stress. What do you mean by thermal stress? See, if a rod is being fixed between two rigid support bed right now. You రెండింటి మధ్యలో ఒక rod పెట్టామనుకోండి. Right now I kept a rod like this and it is being fixed right now here. And you are supplying the heat for this one. You are supplying
Yes,
the
sir.
heat. So what is happening? The rod will slightly try to increase in the length linearly. కానీ ఇక్కడ ఫిక్స్ ఉండడం వల్ల ఏమైపోతుంది? There will be a small bending you will be seeing in this one like this. This bending in the rod because of this heat supply is called as a what? Thermal stress.
Yes, sir.
So stress is equals to how much for me formula? Stress is equals to your force divided by your area.
Yes,
And
sir.
why it has an Young's modulus beta? Young's modulus Y is known as of your thermal stress divided by thermal strain. Thermal strain. Okay, strain formula in the strain is equals to change in length divided by original length. Okay, and we know
Yes,
that
sir.
for linear wires alpha is equals to delta L divided by L into your delta theta. That means change in length by original length can also be written as alpha into delta theta. Alpha is coefficient of linear expansion, delta T is your temperature difference. So if I need your thermal stress, I can write here thermal stress developed in the rod will be equal to your Young's modulus into your thermal strain. Into your thermal strain. That means that will be equal to your Young's modulus into thermal strain means what beta? Delta L by L. That means that will be equal to Y into delta L by L is how much for me? Alpha into your delta theta. Okay.
Yes, sir.
That means thermal stress ఎంత అవుతుంది right now for me? Thermal stress is equals to, this is an important formula beta. Thermal stress is equals to how much beta? Y into alpha into delta theta. Delta theta is what for me? Temperature difference. Y is known as what beta? Young's modulus. Y is known as what for me? Young's modulus. Young's modulus. And delta theta is what for me? Your temperature difference. This is your temperature difference. Clear? So when a rod is being fixed between two fixed walls, the thermal stress developed in the rod is being given by the formula Y into alpha into delta theta. Thermal stress అంటే ఏంటన్నా force by area కదా. Force by area is equals to Y into alpha into delta T. ఒకవేళ force అడిగాడు అనుకో, F will be equal to YA alpha into your delta theta. I can write like this also.
Yes, sir.
So this is the force between them. Very important area. Okay, na?
Yes, sir.
So very important formula. So be a little bit careful related to this one because so many times there was a question directly based on this one in your JEE means based on your thermal stress. Clear?
Yes, sir.
And one very important area in this one which will come generally is your bimetallic strip. Actually, we don't have much time to go in detail, but just try to remember the relation. That is more than enough. What do you mean by bimetallic beta? Bimetallic means it is a combination of your two different metals, isn't it? It is a combination
Yes,
of your two different metals. Like say from here to here, there is one metal.
Fire alarms లో యూజ్ అవుతుంది కదా.
So this one is right now one metal right now like this, and there is another metal like this.
ఒక మెటల్ ఎక్స్పాండ్ అవుతుంది, ఒకటి కాంట్రాక్ట్ అవుతుంది.
ఇంకోటి కాంట్రాక్ట్ అవుతుంది. This is alpha 1 and alpha 2. దీని thickness వచ్చేసి T. So when you heat it, what is happening? This will try to bend something like this.
Yes, sir.
Isn't it? So this will be your bending, and this will be your radius for this. Isn't it? And this is making total angle of your theta. Okay. So if alpha 1 is greater than alpha 2, so this will be the relation. That means this radius, whatever you are calculating, R value will be equal to your T divided by your alpha 1 minus of your alpha 2. Alpha 1 minus of your alpha 2 into your temperature difference delta T. Condition. Okay, na?
Yes, sir.
ఒకవేళ alpha 2 is greater than alpha 1. If alpha 2 is greater than alpha 1, దీంట్లో ఈ condition లో, then the shape will become like this. something like this. Roughly, this is an angle theta, this is your radius r. So at that time, how do you calculate the radius of this bimetallic strip? Means r is equals to t divided by, here it is alpha 2 minus alpha 1 into your temperature difference delta t. Delta T is what here with a temperature difference. Delta T is what here right now for me? Temperature difference, not time. Clear?
Yes, sir.
So these are the some of the standard formulas you need to remember in your thermal properties of your matter in the solids part especially.
Yes, sir.
What do you mean by bimetallic strip? If alpha 1 is greater than alpha 2, this will be the shape. And if it is alpha 2 is greater than alpha 1, this will be the shape. Depending upon that one, we'll be writing the radius of your curvature. Clear, beta?
Yes, sir.
And in yesterday's session, I forgot to tell you about your graph questions better in the latent heat particulation. During phase transformation, phase transformation means solid to liquid, liquid to vapor. Like ice converting to water, water converting into your vapor. Okay. So if I take a graph right now for this, not like this. So we are having some state here right now, beta. Like this. Then this will become for me a straight line. Then again it will increase. Then again it will become straight line. Then finally it will become for me a straight line like this. What do you mean by this one is I'll tell you here. Here I'm taking on your y-axis temperature in your degree centigrade. On x-axis I'm taking your heat. So this is at a temperature of your minus T1 degrees centigrade. This is point A. This is your point B. This is your point C. This is your point D. This is your point E. And this is your point F. Clear, beta?
Yes, sir.
That means what? Can you tell me? This one is at your temperature of your T2. And this one is at a temperature of your T3. Isn't it? And go on. Here the heat required is like say Q1. Here it is Q2. Here it is Q3. And here it is your Q4. Okay.
Yes, sir.
You are converting your ice to water first. That means minus T degrees centigrade will become for me your some T2. Then it will change the state. That means from A to B, if I'm writing here, you see, A to B represents me your solid state, ice. Okay. And what is T2?
Yes, sir.
T2 is your melting point. T2 is your melting point. That means the ice is converting into right now what? Water. Okay.
Yes, sir.
Then in the same way right now, CD. What will be the value of CD beta? CD is right now in which state? Liquid state. Because ice has been converted into water, na? That means T3 will represent me what beta? Boiling point. From C to D, water is rising in temperature, it is converting. From A to B, it is a solid. Then from B to C, the solid is converting into the liquid. Then from C to D, it is in the liquid stage right now completely. That means at T3, it is at what temperature for me? Boiling. Then E to F will be equal to, it is completely into the steam or in the form of your vapor. Clear?
Yes, sir.
Now, how do you calculate this value of Q1 here? Q1 will be equal to your M into your specific heat of your, the solid, whatever you are taking. Specific heat of your solid into your change in temperature. That is T2 plus of your T1 either. In the T2 minus of minus gada. Ikkada.
Yes, sir.
Then what will be the value of Q2 beta? Q2 minus of your Q1. This will be which stage right now? Converting stage. So Q2 minus of your Q1 will be equal to M into latent heat of your fusion. The same way, Q3 minus of Q2 will be equal to your M into specific heat of liquid into your T3 minus of your T2. And in the same way, Q4 minus of your Q3, Q4 minus of your Q3 will be equal to M into latent heat of your vapor. These are the states you need to do for doing the numerical problems.
Yes, sir.
Yeah. Should I do some problems based on this one? Calorimeter, exclusive and calorimeter.
Yes, sir.
Let me check whether I got any paper or something like that. There was some question paper today. Just a minute.
Yes, sir.
I've studied your paper, yes.
Yes, sir.
Only on calorimetry today there was some exam, some good questions. We'll try to do it out from that one.
Okay, sir.
See this question. Graphical question.
Sir, screen share off.
Screen share avadam leda. See this one.
Yes, sir.
See this question. Read it.
Five kg substance ಅನ್ನೋದು.
Question number 20. Are you able to see the screen?
Yes, sir.
Sure. The graph shown in the figure represents the change in temperature of 5 kg of the substance as it absorbs the heat at a constant rate of 42 kilojoules per minute. 5 kg of a substance. The latent heat of vaporization of the substance is how much? The latent heat of vaporization of your substance is your how much? So dq by dt is given how much better?
42.
Divided by time only, na?
Yes, sir.
Isn't it? So dq by your dt.
dt, yes, sir.
dq by your dt. dq divided by your dt.
dt.
Is equals to how much for me? 42 kilojoules
kj.
per minute.
Yes, sir.
Kilojoule per minute. Isn't it? Now see in
Yes,
the graph, temperature versus your time graph he has given for me. Isn't it? So in the time right now, see from 30 to 35. And say from your 25 to 30. What is the condition here? The graph shown in the figure represents the change in temperature of 5 kg of substance and it observes the heat at a constant rate. The latent heat of your vaporization will be equal to how much? That means L is asking us to calculate. Isn't
Yes,
it?
sir.
So that means Q is equals to how much, Varni? Q is equals to your M into your L. So we need to calculate the value of your Q. Okay. Now this graph, what I
Yes,
told you
sir.
better just now, this graph will represents me what? Change in stage.
Yes, sir.
That means solid is converting into liquid. And
Liquid.
this represents me the stage where we are converting the
Gas.
water into the vapor.
Yes, sir.
Isn't it? So water into the vapor. That means this point is your phase change, I can say. So phase change ekkada nunchi ekkada varaku avutundi chudu. So from here, if I'm saying right now, it is from 20, and from here to here, this one is your 30. So in a time
Yes,
of
sir.
your 20 to 30, there is a phase change. That means it is converting into vapor. See, here it is a solid stage. Solid is converting into the liquid here. And here the liquid is converting into vapor or steam. Got
Yes,
an idea?
sir. Yes, sir.
Isn't it? So now for the heat taken for the vaporization means what I can write better. So at what time you are taking right now? So the time is between 30 to 20 to this one 10 minutes. 30 minus 20, that will be equal to 10 minutes.
Yes, sir.
So by dq by dt in that much time will be equal to how much beta? Therefore dq by dt will be equal to your how much will be 42 into your 10. That means this will be equal to your 420 kilojoules. Antena?
Yes, sir.
Got an idea how I got it, the value of dq by dt?
Yes, sir.
Isn't it? Now use the formula q is equal to m into your L. Q value is the right now. Q value is equals to how much for me?
420.
420 is equals to mass is given how much in the problem? 5 kg into
Yes,
latent
sir.
rate of vaporization. So latent
Yes,
rate of
sir.
vaporization is how much for me? 420 divided by 5.
84.
5 rates of 40, that means it is 84. 84 kilojoule per your kg.
kg.
That means this one. Got an idea how to do the graph question?
Yes, sir.
Clear వచ్చిందా?
Yes, sir.
ఇంకో క్వశ్చన్ కూడా చూసుకో దీంట్లో. You try to give me the answer for this graph. A solid metal is supplied with heat at a constant rate. The temperature of the metal is changing with the heat input as shown in the figure. What does the slope dE represents? Very good question.
Latent heat of vaporization.
Latent rate of your vaporization. That means this is the slope only, na? This is the slope what it is exactly representing. So this
Yes,
is the
sir.
graph right now for this one.
Yes, sir.
Isn't
Heat
it?
of vaporization.
Heat of your vaporization. That means heat of your vaporization on the latent heat of your vapor. So here it is converting
Second
into the
option.
steam. Here it is converting into the steam. That means slope of this dE will be equal to how much beta? Temperature divided by heat. Because this is the graph between temperature and heat input. See the graph. Y-axis la temperature on the x-axis la heat on the.
Yes,
Means
sir.
what is the slope of this one beta? Slope of your dE will be equal to y by x kada. Y ante emundi change in temperature divided by heat. Change in temperature divided by heat means I can even write this one as heat divided by temperature to the power of -1.
Yes, sir.
Heat divided by temperature means what for me? For me relation. Q is equals to m into s into delta theta. Isn't it?
Yes, sir.
So Q by delta theta will be equal to how much beta? Q by delta theta will be equal to m into your s kada. Mass is any of constant.
Yes, sir.
That means Q by delta theta inverse means what it will be? 1 by s only, na? That means it will be inverse of what? Heat capacity of vapor.
Yes, sir.
Very good question. Okay, na?
Yes, sir.
Question number 18, Jodu. 420 joules of energy is being supplied to 10 gram of water will raise its temperature by nearly how much? How much amount of the joule? 420 joule of energy is being supplied to 10 gram of water will raise its temperature to nearly how much? That means I can use the relation Q is equals to ms into your delta T.
Yes, sir.
Q value is given how much for me? 420 joules. That
420.
is equals to mass is given how much? 10 grams. 10 into 10 to the power of 3 into specific heat of your water will be in the grams will be in the kgs will be 4,200 into temperature delta T.
Sir, multiply by 10 raised to 3 ఎందుకు?
Grams kada? 10 grams.
Yes, sir.
Isn't it?
Yes, sir. Yes, sir.
Sure. And specific heat of water is equals to 4,200. So delta theta is how much for me? What are the options? 1 degree, 4.2, 10 degree, 42. Interesting good answer. 420 ones, 420 tens. Antena?
సార్ థర్డ్ ఆప్షన్ అవుతుంది
10 degrees. అంతేనా?
కానీ ఇక్కడ మైనస్ ఉండాలి కదా?
మైనస్ ఎక్కడ?
10⁻³ ఉండాలి కదా?
10⁻³ ఉండాలి. అంతే కదా?
ఎస్ సార్. ఇప్పుడు వస్తున్నారు
1000 grams will be equal to your 1 kg.
Yes sir.
So 1 gram will be equal to your how much?
10⁻³.
Okay.
Yes sir.
Got an idea?
Yes sir.
Sure. Given questions on the tutor, you can do it out right now. Can you do this question number 15? Amount of heat required to convert 1 gram of ice at 0 degrees centigrade into steam at your 100 degrees centigrade will be equal to how much?
Same sir. Q equal to ms delta T.
Amount of heat required to convert 1 gram of your ice. That means
M will be equal to 10⁻³
Ice you are converting into what beta? Ice at 0 degrees centigrade will convert into what? Water at 0 degrees centigrade?
Yes
water
sir.
at 0 degrees centigrade will convert into 100 degrees centigrade of water. And 100
Yes,
degrees
sir.
centigrade of water will convert into what beta? 100 degrees
Steam.
centigrade of your steam. Isn't it? From here to here,
Yes,
this
sir.
one is right now ice. There is no change in your temperature. That means this is M into L of ice I can use. Here ms into your delta theta. And here it is M into L of your vapor.
Yes sir.
So Q will be equal to mass in the third 1. So 1 into latent heat of your that value fusion is how much will be beta? 80. Then plus mass of water is 1, specific heat of water is 1 into Q is equal to how much? Temperature difference is right now 100. This one is a plus, mass is again 1 into latent heat of fusion will be equal to how much will be 540. And then so it is your 80 plus of your 100 plus of your 540.
Yes sir.
And 80 plus 100 plus 540.
720.
720 ante what I can write the answer right now?
716 approximately.
So
Yes, sir.
questions you can do such type of questions on that one, right?
Okay sir.
Here's a question. Question number 9. Good question. Good, sir. Read the question number 9. A bullet is moving with a velocity v, collides against a wall. Consequently, half of its kinetic energy is converted into heat. If the whole heat is being acquired by the bullet, the rise in temperature will be equal to how much? Joule's law formula. Bullet is possessing what type of energy, beta?
Kinetic.
So
Yes, sir.
W is equals to J into your Q.
Yes sir.
Isn't it? So this is the form of kinetic energy. This is equals to half into what is telling in the problem. Half of its kinetic energy, this is half into M into your V square. Is equals to J value is nothing but equal to 1. Q is equals to ms into your delta theta. Is asking us to calculate the value of your delta theta. And then rise in temperature of the bullet. So this will become for me M into V square divided by 4 is equals to your M into specific heat into your delta theta. This mass and this mass will also get cancelled. So delta theta will be equal to V square divided by 4 into your S. First
Yes sir.
What an idea? This W
Yes,
is
sir.
equal to J into Q is known as what law beta? Joule's law. Heat loss. This one is a Joule's law. So this can be anything, but if it is a potential energy, use MGH. If it is a magnetic energy, you can use magnetic energy. If it is a capacitor energy, whatever energy it is, that energy must be equal to J into Q. J is your mechanical equivalent of heat.
Yes sir.
Okay, na?
Yes sir.
Okay, chalo. Take care, beta. We'll try to
Yes,
do
sir.
some topic. Again, topics are under such a pool. I'll send you that one. We'll try to do it out in extra class this one and computer system.
Okay sir.
Time కూడా లేదు మనకి ఈరోజు 23rd 24 25 26 ఒక 2-3 days లో మనం కంప్లీట్ చేసుకోవాలి ఏదైనా రాని టాపిక్స్ ఉంటాయి ఓకేనా
Yes sir. Yes sir.
టేక్ కేర్ బేటా బై
Bye sir. Thank you.